What is subjective probability?
As the word implies, a subjective probability is thought of as a personal degree of belief that a particular event will occur. An individual's personal judgment is not based on any precise computation, but is most often a reasonable assessment of what will happen by a knowledgeable person. This is usually expressed on a scale of 1 to 0, or on the percentage scale. For example, if a person's baseball team has a winning streak, they might believe that their team has a probability of 0.9 of winning the division championship for the year. More likely, they will say their team has a 90% chance of winning. Not because of any mathematical formula, but only because the team has had a winning record during the year.
What does it mean if a set is countable?
If a set is countable, or denumerable, it means that it is finite. This also means that the set's members can be matched in a one-to-one correspondence in which each element in one set is matched exactly with one element in the second, and vice versa with all the natural numbers, or with a subset of the natural numbers. Mathematicians often say, A and B are in one-to-one correspondence, or A and B are bijective. For more about one-to-one correspondence, see Math Basics. In set theory, all finite sets are considered to be countable, as are all subsets of the natural numbers and integers. But sets such as real numbers, points on a line, and complex numbers are not countable.
What are the conditions in reference to differential equations?
In general, there are two conditions when discussing differential equations.
What is the connection between counting and mathematics?
Although early counting is usually not considered to be mathematics, mathematics began with counting. Ancient peoples apparently used counting to keep track of sundry items, such as animals or lunar and solar movements. But it was only when agriculture, business, and industry began that the true development of mathematics became a necessity.
What is chance?
Mathematically speaking, chance is a measure of how likely it is that an event will occur, a probability. For more about chance and probability, see Applied Mathematics.
What is the origin of Roman numerals?
Because the history of Roman numerals is not well documented, Their origin is highly debated. It is thought that the numerals were developed around 500 BCE. Partially from primitive Greek alphabet symbols that were not incorporated into Latin. The actual reasons for the 7 standard symbols are also argued. Some researchers believe the symbol for 1, I, was derived from one digit on the hand, the symbol for 5, V, may have developed because the outstretched hand held vertically forms a V from the space between the thumb and first finger. The symbol for 10, X, may have been 2 V's joined at the points. Or it may have had to do with the way people or merchants used their hands to count in a way that resembled an X. All the reasons offered so far have merely been educated guesses. However the symbols were developed. They were used with efficiency and with remarkable aptitude by the Romans. Unlike the ancient Greeks, the Romans weren't truly interested in pure math, such as abstract geometry. Instead, they concentrated on applied math, using mathematics and their Roman numerals for more practical purposes, such as building roads, temples, bridges, and aqueducts, for keeping merchant accounts, and for managing supplies for their armies. Centuries after the Roman Empire fell, various cultures continued to use Roman numerals. Even today, the symbols are still in existence. They are used on certain timepieces, in formal documents, and for listing dates in the form of years. For example, just watch the end credits of your favorite movie or television program, and you will often see the movie's copyright date represented with Roman numerals.
Why is Greenwich, England, called the prime meridian?
The reason for Greenwich, England, being the prime meridian is historical. An imaginary line passes through the old Royal Astronomical Observatory, which was chosen by astronomers of the day as zero longitude. The observatory is now a public museum located at the eastern edge of London. It is a great spot for tourists who can find there a long strip of brass that stretches across the yard marking the prime meridian. Here it is possible to straddle the line with one foot in the Earth's eastern hemisphere and the other in the western hemisphere.
What early mathematicians are thought to be responsible for originating the use of algebraic methods and ideas?
To some scholars, Greek, Hellenic, mathematician Diophantus, c. 210 c. 290, is considered the father of algebra, as he developed his own algebraic notation. His words were noted and preserved by the Arabs. The translation of his words into Latin in the 16th century led to many algebraic advances. In more modern times, French mathematician François Vide, 1540 to 1603, also known by the Latin name Franciscus Vitae, is often credited as the founder of modern algebra. For more information about Diophantus and Veit, see below and History of Mathematics.
What are quadrants?
Graphs used in the Cartesian coordinate system are broken down into quadrants, or 4 segments. For example, in a two-dimensional system, the x and y axis with the origin as 0 and the two axes perpendicular to each other form the 4 quadrants. In the top left quadrant, quadrant 2, the x is negative and the y is positive. In the top right quadrant, quadrant I, both coordinates are positive. In the bottom left quadrant, quadrant 3, Cartesian coordinates are both negative. And in the bottom right quadrant, quadrant 4, the x is positive and the y is negative.
What is the historical basis for mathematical logic?
Most mathematicians believe that systematic logic began with Aristotle's collection of works titled Organon. Tool, in which he introduced his ideas on logic. In particular, Aristotle used general forms to describe logic, such as if all x are y, and all y are z, then all x are z. He presented 3 laws basic to all valid thought: the law of identity, or A is A, for example. An acorn will always yield an oak tree and nothing else; the law of contradiction, or A cannot be both A and not A. For example, an honest woman cannot be a thief, and the law of the excluded middle. Or either or, in which A must either be A or not A, for example, a dog can be brown or not brown. Interestingly, author Ayn Rand divided her novel Atlas Shrugged into 3 parts after these 3 principles as a tribute to Aristotle.
What is mean sea level?
Mean sea level, MSL, is the average water level, height of the sea, for all stages of a tide. Locally, MSL is measured by tidal gauges at one or more points over a given period of time. The resulting numbers average out wind waves and other periodic changes in sea level. The overall values of a MSL are measured with respect to level marks on land called benchmarks. Thus, scientists know a true change in MSL is either from a change in sea level from, for example, possible global warming effects, or changes in the gauge's height on land, such as in the case of local uplift. There is also a more mathematically intensive way to determine the MSL. To a geodesist, a person who studies the shape of the Earth, MSL is determined by comparing measured heights of the global mean sea surface, MSS, above a level reference surface called a geoid, a mathematical model of an ellipsoid shape that approximates Earth's mean sea level. This comparison is done because the Earth does not have a geometrically perfect shape. For example, the Atlantic Ocean north of the Gulf Stream is about 3.3 feet, 1 meter, lower than it is farther south. The MSS is not a level surface, thanks to such factors as currents created by wind, as well as atmospheric cooling and heating that cause differences in sea levels around the world. But interestingly enough, it never differs from the global geoid by more than about 6.56 feet, 2 meters.
What are some well-known axiomatic systems?
One of the most well-known axiomatic systems was developed by the Greek mathematician Euclid, c. 325 c. 270 BCE. He presented 13 books of geometry and other mathematics titled Elements, or stoicheion in Greek. Included in these books were theorems about geometry and numbers derived from 5 postulates about points, lines, circles, and angles. 4 axioms about equality, and 1 axiom stating the whole is greater than the part. A more modern axiomatic system is the axiomatic set theory, which is based on 8 axioms and 3 undefined terms.
How are studies of fluid mechanics used today?
The list of engineering uses of fluid mechanics in the modern world seems endless, and no wonder, since it is one of the most widely applied areas of mathematics and engineering. Some of today's uses of fluid mechanics in various fields include, understanding the movement of molten liquid, rock, or lava, in volcanic eruptions, studying the flow of air over objects to help design airplanes, the space shuttle, and even spacecraft that fly through the atmospheres of other planets. Airflow studies in the automobile industry to design cars with more aerodynamic profiles, analyzing the ups and downs of the stock market. Examining natural hazards, such as snow conditions that result in an avalanche. Interpreting turbulent flow in sewer and water pipes, and in river channels. Studying complicated flow of weather patterns in the atmosphere, researching the effects of gravity, and other waves in space. And using fluid mechanics applications to study the deep oceans and coastal shorelines, including waves and currents.
What are geometric transformations?
Geometric transformations are rules that mean there is a one-to-one correspondence between two sets of points in two figures. A geometric transformation changes the plane or three-dimensional space. Each transformation can be defined by thinking about where each point is taken, with the point said to be taken to its image. One way to visualize a transformation is to think of expanding, shrinking, or moving one figure to get a second figure. Depending on the transformation, the image will either be congruent, equal, to the original image, called the identity transformation, similar but not necessarily equal, or will not resemble the original at all.
How is mathematics used in physics to describe motion?
Everything in the universe is in motion, from the rotating Earth to subatomic particles. Motion in physics is described mainly through mathematics, including speed, velocity, acceleration. Momentum, force, something that changes the state of rest or motion of an object, torque. When a force causes rotation or twisting around a pivot point, and inertia. A body at rest remains at rest, and a body in motion remains in motion, until acted upon by an outside force. Unlike what most people think, speed and velocity are not the same. Speed is the rate at which something moves, velocity is speed in a certain direction. Speed is also called a scalar quantity, described by the following formula: speed equals distance/time. For example, if you drive 200 miles in 2 hours, and your speed is constant, your average speed is 200/2, or 100 miles per hour. On the other hand, velocity is known as a vector quantity. For more about vectors, see mathematical analysis. That gives velocity both speed and direction, and that leads directly to acceleration. When an object's velocity changes, we say that it accelerates. Acceleration, also a vector like velocity, is represented as the change in velocity divided by the time it takes for the change to occur.
What are proper and improper fractions?
The word fraction to most of us means a part of something. In mathematics, it represents a type of numeral. In most cases, the quotient of two integers, with the top number called the numerator, the number of parts, and the bottom number the denominator, how many parts the whole is divided into. Written out, the numerator and denominator are separated by a slash or dash. A fraction is usually denoted by a/b, in which a and b are whole numbers and b is not equal to 0. For the explanation of why you cannot divide by 0, see above. A rational number between 0 and 1 can be represented by fractions, by the division of two numbers. If the quotient is less than 1, such as 1/2 or 2/5, then it is called a proper fraction. If the quotient is greater than 1, or, in other words, if the numerator of a fraction is larger than the denominator, such as 23/7, it is called an improper fraction.
What is a simulation?
A simulation is an imitation of some real event or device. It is often used interchangeably with the word modeling, as in modeling of natural systems. A simulation tries to represent certain features, or behaviors, of a complex physical system based on the underlying computational models of the phenomenon, environment, or experience. Simulations are used to understand the operation of real-world, practical systems. For instance, the modeling of natural systems such as the human body. They can be used to simulate a certain type of technology, such as a new type of airplane. Or model an engineering concern, such as the stability of a building during an earthquake. Simulators, interactive, physical devices that simulate reality, are also part of simulation. For example, space shuttle simulators are used to help astronauts understand the intricacies and various scenarios associated with flying the space shuttle.
What is meteorology?
Meteorology is the study of atmospheric phenomena, their interactions and processes. It is often considered part of the earth sciences and is most commonly associated with weather and weather forecasting.
When were the first calendars invented?
Although the first crude types of calendars may have appeared some 30,000 years ago, they were based on the movements of the moon and indicated as marks on bones. The Egyptians are given credit for having the first true calendars. Scientists believe that around 4500 BCE the Egyptians needed such a tool to keep track of the Nile River's flooding. From about 4236 BCE, the beginning of the year was chosen as the heliacal rising, when a star is finally seen after being blocked by the sun's light, of the star Sirius, the brightest star in the sky located in the constellation of Canis Major. This occurred, and still occurs, in July, with the Nile flooding shortly after that, which made it a perfect starting point for the Egyptian calendar. The Egyptians divided the calendar into 365 days, but it was not the only calendar they used. There was also one used for planting and growing crops that was dependent on the lunar month.
When was the calculating machine first mass-produced?
Between the 1624 invention of Blaise Pascal's calculating machine and 1820. There were about 25 manufacturers of such devices. Because there were so many, most had little funding and only one person involved. Very few machines were actually manufactured in any quantity. By 1820, the first calculating machine to be commercially successful and produced in large numbers was the arithmometer, invented by Frenchman Charles Xavier Thomas de Colmar, 1785 to 1870, while he was serving in the French army. It was based on a Leibniz step drum mechanism, see above. Colmar's machine used a simple system of counting gears and an automatic carry, automatically shifting a 1 to the left when the sum of a certain column was greater than 9. The technology of the times also helped catapult Colmar's success. because it included springs and other machinery that offset the momentum of moving parts. The arithmometer stopped at a specific, intended point, unlike what often happened with the older calculating machines. One of his first ventures into calculating machines was the difference engine, which was based on Johann Müller's design and some of Thomas de Colmar's arithmometer features. For more information about both, see above. The idea was sound, but the execution eventually lacked government funding. Not to mention suffering from disputes with the artisan who was making the parts for the machine. Not only that, but Babbage's ambitions may have caused the difference engine prototype to come to a halt. Initially, he wanted the device to go to 6 decimal places and a second-order difference. Then he began planning for 20 decimal places and a sixth-order difference. This much larger machine was an overwhelming concept for its time. The abandonment of the difference engine did not stop Babbage, however. Again approaching the government for funding, he promised to build what he called the analytical engine. An improved device capable of any mathematical operation, effectively making it a general-purpose, programmable computer that used punch cards for input. This new device would use a steam engine for power, and its gears would function like the beads of an abacus, with the main tasks of calculating and printing mathematical tables. For 8 years, he attempted to get more money from the government, but to no avail. He would never build his analytical engine.
What is prime factorization?
Many of us are most familiar with prime factorization, which is a way of taking a number and breaking it down into its constituent primes. An example of prime factorization is as follows: one finds the simplest representation of the given quantity in terms of smaller parts. In the case of 15, the factors would be 1, 3, 5, and 15, essentially all the numbers that will divide integrally into 15. Not that prime factorization is always that easy. Larger numbers make it more difficult to factor, and many sophisticated prime algorithms have been devised for larger and different types of numbers.
What do blood pressure numbers mean?
Blood pressure is a measure of how much the blood presses against the walls of the arteries. This creates two forces. The first comes from when the heart pumps blood into the arteries. The second is the force of the arteries to resist the blood flow. When a person takes a blood pressure, he or she is taking a ratio, the higher number, called the systolic or top number, represents the pressure when the heart contracts to pump blood to the body, the lower number, called the diastolic or bottom number, represents the pressure when the heart relaxes between beats. For example, for a blood pressure of 120/76, said, 120/76. The systolic reading is 120 and the diastolic reading is 76. In actuality, the numbers represent how high the blood's pressure would force a column of mercury to rise in a tube. For example, a systolic reading of 120 means the mercury would rise 120 millimeters. Usually labeled mmHg, with Hg the symbol for mercury, in a tube. Based on the most recent information, and it keeps changing, a blood pressure below 120/80 is considered optimal for adults. 120 to 139/80 to 89 is considered pre-hypertension. Anything over 140/90 is considered hypertension, which includes 3 stages. With the highest hypertension reading, stage 3, being anything above 179/109.
How is barometric, or air, pressure measured?
Barometric, or air, pressure, named after the instrument used to measure this pressure, is caused by the weight of the atmosphere pressing down on the land, ocean, and air below, with gravity creating the downward force. Because pressure is dependent on the amount of air above a certain point, pressures are greatest at the surface and less at higher altitudes. On the average, at sea level, the air has a pressure of 14.7 pounds per square inch. A 1-inch square has 14.7 pounds of air pressure on each side. The United States National Weather Service does not measure pressure in pounds per square inch, but in terms of inches of mercury, or how high the pressure pushes mercury in a sealed tube. Air pressure aloft is reported in millibars, or hectopascals HPA. A term most often used by scientists to measure air pressure. Most of us are very familiar with air pressure as it changes with the weather. For example, the use of the terms high pressure system and low pressure systems are often indicators of the types of weather fronts traveling through a region. In general, falling air pressure, seen on a barometer, means that clouds and precipitation are more likely. Rising air pressure means that clear weather is more likely. In addition, many people experience personal changes in air pressure. For example, the discomfort or even pain felt in a person's ears as they ascend or descend in an airplane. A large hill, or even in an elevator, is evidence of changing air pressure.
Do numbers continue into infinity?
When most of us think of infinity, we envision the universe continuing on forever. And in mathematics, we often think of numbers that are never ending. Sometimes it is difficult to understand infinity. Since our own lives and most of our experiences are finite, they eventually end. Infinity is a mind-boggling concept. There are several rules to mathematical infinity. The 3 most important are: no matter how high you count numbers, you can always count higher. No matter what length you draw parallel lines, they will never meet, and when starting with a line, dividing it in half. Then dividing that in half, and so on, you will never stop dividing the resulting line segment. Even though scientists and mathematicians agree that infinity exists theoretically, it is often a difficult concept to understand and accept.
Who was Vitruvius?
Marcus Vitruvius Pollio, c. 1st century BCE, was a Roman writer, architect, and engineer. He was the author of De Architectura Libri de Cm, known today as the 10 Books of Architecture. This Latin treatise, dedicated to Octavian, the heir and adopted son of Julius Caesar, was written around 27 BCE. For more about Octavian, see Mathematics Throughout History. Possibly the first works published about architecture, the books entailed a compilation of architectural ideas of Vitruvius's day and covered the following 10 subjects: principles of architecture, history of architecture and architectural materials, Ionic temples, Doric and Corinthian temples, public buildings, theaters, music, baths and harbors, town and country houses, interior decoration, water supply, dials and clocks, and mechanical engineering with military applications. Specifically, the topics included such forward-thinking ideas as the manufacture of building materials and dyes, material science, machines for heating water for public baths, chemical engineering, amplification in amphitheaters, acoustical engineering, and the design of roads and bridges, civil engineering. De Architectura was wildly successful, and Vitruvius's architectural advice was followed for centuries. But because Vitruvius's books were passed down through the ages, they were copied by various people, especially throughout the Middle Ages. Many medieval engineers added information to the texts, treating the books as handbooks, not documents to be preserved. In the end, historians have had to winnow away the added sections to find the true writings of Vitruvius.
What is interest and how is it calculated?
In finance, interest can be viewed in two ways: the interest given to a person on money loaned to, deposited in, a bank or financial institution, or as a fee, payment. For borrowing or lending money, most often based on a percentage of the requested amount. The two most common types of interest are simple and compound. For more information on interest, see Everyday Math. In terms of a savings account, the interest is usually compounded, which means that any interest earned is reinvested, or compounded, to generate even more money, and thus increase future interest. Take, for example, a person starting with $1,000 in a money market fund earning 5% per year with quarterly interest payments. Or the person gets 5% divided by 4, or 1.25% per quarter. After 1 year, the $1,000 has grown to $1,050.95, making the compound interest rate actually 5.095%, not 5.00%, because interest was also paid on the accumulated interest for each quarter. An interest of 5% only is called the simple interest rate. But most banking institutions pay compound interest on savings. Simple and compound interest are both used in borrowing and lending. With simple interest, the interest is paid strictly on the amount of the initial principal. Original amount borrowed or lent, which is usually represented by the formula A, T, equals A, 0, 1 plus RT, in which A, T, is the sum of the principal and interest at the time T for a constant interest rate R. Compound interest has a more complex formula. This type of interest is calculated not only on the initial principal, but also the interest accumulated, or accrued, over time. For example, a person purchases a home for $250,000 and pays $50,000 as a down payment. The remaining $200,000 is taken out as a loan at 8% interest for 30 years. Compounded monthly, with equal monthly payments. The monthly mortgage payment, M, in which P is the principal, I is the interest rate, N is the number of years, and Q is the number of pay periods per year, would be M equals pi slash Q, 1 plus I slash Q, NQ, equals $200,000, 0.08, slash, 12, 1 plus, 0.08 slash 12, dash, 30, 12, equals, $1,333.333333 slash, 11.00666666, dash 360, equals $1,467.
What are proofs and theorems in geometry?
Proofs are extremely important to geometry. Similar to other divisions of mathematics, proofs are defined as sequences of justified conclusions used to prove the validity of an if-then statement. For more information about postulates, theorems, and undefined terms, see Foundations of Mathematics. There are essentially 5 steps in showing that any proof is a good proof. State the theorem to be proved, list what information is available. Draw an illustration, if possible, to represent the information, state what is to be proved. Finally, develop a system of deductive reasoning, especially concentrating on statements that are accepted to be true. Along with the true statements, add any necessary undefined terms. In geometry, in order to prove a theorem, you need to use definitions, properties, rules, undefined terms, postulates, and possibly other theorems, and like hyperlinking to other text with internet links. Such theorems can be used throughout geometry, and other mathematics, in the proofs of other new, more difficult theorems.
What is logic?
Although it closely resembles mathematics, and is sometimes used as a basis for it. Logic is a branch of knowledge or inquiry that is separate from mathematics and the sciences. But it is still used by both fields in various ways. Simply put, logic is described as the systematic study of well-founded inference, in which there is a definite distinction between logical validity, also known as the formal properties of the inference process, and truth. This also means that a true result may come from an invalid argument. See below for the definition of an argument. For example, all cats are cute, Fluffer is a cat, therefore, Fluffer is cute, is a valid inference, whereas, all cats are cute, Fluffer is cute, therefore, Fluffer is a cat, is an invalid inference, even if Fluffer really is a cat.
What are calories?
To most people, calories are usually associated with a very large piece of chocolate cake. But in that case, they are called nutritionists' calories, or the unit of energy producing potential, equal to the amount of heat that is contained in food and released upon oxidation by the body. The body needs the calories in the foods we eat to use as energy. This is why nutrition and weight control texts often contain such entries as a 140-pound person walking for 1 hour at a moderate pace burns off 222 calories. In chemistry, a calorie also refers to a unit of energy. But in terms of chemical experiments, a calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius from a standard initial temperature at a pressure of 1 atmosphere, sea level. The unit measurement for energy is a joule, in which 1 calorie equals 4.184 joules, 1 joule is translated most often in metric, as the energy needed to lift 2000 grams a distance of 10 centimeters.
Who was responsible for expanding the ideas of predicate calculus?
He German philosopher and mathematician Friedrich Ludwig Gottlob Frege. 1848 to 1925, presented a way to rearrange sentences to make their logic clearer and to show how the sentences relate in various ways in his 1879 treatise, Begriffsschrift, German for Konzeptschrift. Before Frege began his work, formal logic, in the form of propositional or sentential calculus, see above, used such words as and, or, and so on. But the method could not break the sentences down into smaller parts. For example, formal logic could not show how the sentence cats are animals actually entails parts of cats are parts of animals. Frege added words such as all, some, and none, using variables and quantifiers to rearrange the sentences. therefore making them more precise in their meaning. He also developed two of the major qualifier symbols for predicate calculus: the upside down A, V, and the backward E, 3. Freya's work was the foundation for modern logical theory. Even though his work was defective in several respects and was considered awkward to use. By the 1910s and 1920s, Freya's system was modified and streamlined into today's predicate calculus.
What is a common example of mathematical modeling?
One of the most common examples of a mathematical model has to do with the growth of populations, human, animal, or otherwise. In the sciences, this type of mathematical modeling often leads to intelligent hypotheses about the future and past of a population, from a possible population explosion to even an extinction. For more information about the use of mathematical modeling in the sciences, see Math in the Natural Sciences.
What is set theory?
Set theory is the mathematical theory of sets and is associated with logic. It is also considered the study of sets, collections of objects or entities. That can be real objects or intellectual concepts, and their properties. For more about sets, see below. Under formal set theory, 3 primitives. Undefined terms are used: S, the set; I, the identity; and E, the element. Thus, the formulas Sx, Xe, Xe mean X is a set. X is identical to Y, and X is an element of Y, respectively. Overall, set theory fits in with the aims of logic research. To find a single formula theory that will unify and become the basis for all of mathematics. As it turns out, sets lead directly to a vast amount of data encompassing all of modern mathematics. There are also a number of different set theories, each having its own rules and axioms. No matter what version, set theory is not only important to mathematics and logic but also to other fields, such as computer technology and atomic and nuclear physics.
Who were John Grunt and Sir William Petty?
English statistician John Grunt, 1620-1674, is generally considered to be the founder of the science of demography, which is the statistical study of human populations. In 1661, after analyzing some major statistics of the London populace, he wrote what is considered the first book on statistics, natural and political observations upon the bills of mortality. The bills of mortality refers to the collections of mortality figures in London, a city that had suffered greatly from the outbreak of several plagues. Because the king wanted an early warning system of new outbreaks, Weekly mortality records were kept, along with the causes of death. Based on this information, Grunt made an estimate of London's population. That is thought to be the first time anyone interpreted such data. It is therefore considered by some to mark the beginnings of population statistics. Grunt's work influenced his friend, Sir William Petty, 1737 to 1805. He also influenced Edmund Halley, the astronomer and discoverer of Comet Halley. For more about Halley, see Mathematics in the Physical Sciences. Petty's work was a bit more practical and political. He wanted to set up a central statistical office for the English crown in order to make estimates about the sum of England's overall wealth. His unusual approach was to assume that the national income was the same as the total national consumption. He didn't forget about the plague, but added estimates of losses to the national economy due to the plague. From there, he suggested that modest investment by the state to prevent deaths from plague would produce abundant economic benefits.
For example, take the sequence of numbers used above, or xnn.
Often the numbers come closer and closer to a number we'll call L, written in calculus, xn equals L. If the numbers do come closer, the sequence is said to be convergent and has a limit equal to L. Conversely, if the sequence is not convergent, it is called divergent. Most mathematicians and scientists are not only interested in how a sequence converges or diverges, but also how fast it converges, which is called the speed of convergence. There are several basic properties of the limits of a sequence, including that the limit of a convergent sequence is unique. Every convergent sequence is bounded, and any bounded increasing or decreasing sequence is convergent.
What is a proof?
A proof is simply the process of showing a theorem to be correct. Although the process itself might not be simple, these mathematical arguments are often quite rigorous, and they are used to demonstrate the truth of a given proposition. The result of the proved statement is a theorem. Interestingly enough, there are several computer systems now being developed to automate proofs. But some mathematicians, mostly purists, do not believe these computer-assisted proofs are valid. They believe that only humans can understand the nuances and have the intuition needed to develop a theorem's proof. One good example is called the four-color theorem. Its proof relies on meticulous computer testing of many separate cases, all of which can't be verified by hand.
What are some of the basic building blocks of geometry?
There are several basic building blocks of geometry, all of which have to do with the objects we often see in geometry. A zero-dimensional object that is specifically located in n-dimensional space using n coordinates is called a point. The idea of a point may be obvious to most people, but for mathematicians, describing and dealing with points is not straightforward. For example, Euclid once gave a vague definition of a point as that which has no part. Euclid also called the line a breadthless length, and further called a straight line one that lies evenly with the points on itself. Modern mathematicians define lines as one-dimensional objects. Although they may be part of a higher dimensional space, they are mathematically defined as a theoretical course of a moving point that is thought to have length but no other dimension. They are often called straight lines, or by the archaic term, a right line, to emphasize the fact that there are no curves anywhere along the entire length. It is interesting to note that when geometry is used in an axiomatic system, a line is usually considered an undefined term. For more about axiomatic systems, see Foundations of Mathematics. In analytic geometry, a line is defined by the basic equation x plus y equals c, in which a, b, and c are any number, but a and b can't be zero at the same time. A line segment is the shortest curve which is actually straight to connect two different points. It is a finite portion of an infinite line. Line segments are most often labeled with two letters corresponding to the endpoints of the line segment, such as a and b, and written as a b. Distance is the length of the path between 2 points, or the length of a segment, for example, between points A and B. When talking about the distance between any 2 points associated with A and B as real numbers, on a number line, distance becomes the absolute value of BA. Another basic building block is the ray. Think of a ray as a laser beam. It originates at one point and continues in one direction toward infinity. A ray is defined as part of a line on one side of a point, and includes that point. 2 letters are needed to name a ray. For example, ray of is defined by point A, where it begins, and point B, the point the ray goes through. But note, ray of is not the same as ray BA. If the initial point is not included, the resulting figure is called a half-line. In geometry, a ray is usually considered a half-infinite line, with one of the 2 points A and B taken to be at infinity.
What is a random walk?
Although one might think of a random walk as one that a person takes on the spur of the moment in a part of town he has never walked before, it means something totally different in probability theory. A random walk is a random process made up of a discrete sequence of steps, all of a fixed length. For example, in physics, the collisions of molecules in a gas are considered a random walk that are responsible for diffusion. The number of permutations is the number of different ways specific entities within the ket group can be arranged, with the positions being important.
How is the Pythagorean theorem connected to right triangles?
The Pythagorean theorem deals with right triangles, simply stated. The sum of the squares of the legs equals the square of the hypotenuse, longest side. The converse of the Pythagorean theorem is also true, if the sum of the squares of a triangle's two sides equals the square of the longest side, then the triangle is a right triangle. For an illustration of the Pythagorean theorem, see History of Mathematics.
What is the degree of a polynomial equation?
The highest order power, or exponent, used in a univariate polynomial is called its polynomial degree or order. It is also defined as the largest, or maximum, sum of exponents that appear on the variables in the equation's terms. Commonly, the word degree is used more frequently because order has another meaning when discussing polynomials. You can also talk about degrees in reference to monomials, binomials, and trinomials. The degree of a monomial is the sum of the degrees of the variable in the equation. The degrees of the other polynomial equations are the greatest of the degrees in terms after the equation has been simplified. For example, a third-degree trinomial equation is x3 3x2 equals 0.
What are hyperbolic and elliptical geometry?
Hyperbolic and elliptical geometry are the non-Euclidean alternative geometries mentioned above. The first alternative is to allow two parallels through any particular external point or hyperbolic geometry. This studies two rays extending out in either direction from a point P and not meeting a line L, thus, the rays are considered to be parallel to L. This also helps prove the theorem that the sum of the angles of a triangle is less than 180 degrees. It is called hyperbolic because a line in the hyperbolic plane has 2 points at infinity. This is similar to drawing a hyperbola that has 2 asymptotes. The second alternative, called elliptical geometry, has no parallels to a given line L through an external point P. In addition, the sum of a triangle's angles is greater than 180 degrees. Sometimes called Riemann's geometry, who developed the idea even further, see below. It is called elliptic in general because a line in the plane of this geometry has no point at infinity, where parallels may intersect it, which is similar to an ellipse that has no asymptotes. For more information about hyperbolas, ellipses, and asymptotes, see elsewhere in this chapter.
What is engineering?
Engineering is a discipline that deals with the art or science of applying scientific knowledge to solve practical problems, usually in the areas of commerce and industry. Scientists ask the why of a question, then research the answer. In contrast, engineers want to know how to solve the problem and then how to implement the solution. But it's not always easy to separate the two. Often a scientist has to use engineering basics, such as building special equipment for research. And engineers often have to do scientific research. The word engineer, as well as engine, developed from the Latin root ingenius, skilled. In some languages, such as Arabic, the word for engineering also means geometry. The various branches of engineering include aerospace, agriculture, architectural, biomedical, computer, civil, chemical, electrical, environmental, mechanical, petroleum, and material science.
What is geology?
The word geology comes from the Greek geo, meaning the earth. And the ology suffix comes from logos, meaning discussion. Overall, geology is considered to be the study of the earth. In modern times, thanks to space probes reaching into the solar system, geology also now entails the surface features on other planets and satellites.
What is a magic square?
A magic square is an array of numbers in an n by n square that contains positive integers from 1 to n2 with each number occurring only once. The numbers in the squares are arranged so that the sum in any horizontal, vertical, or main diagonal direction is always the same. This is shown in the following formula: n2 plus 1, / 2. Magic squares are often divided into orders. For example, a 3-order magic square means 3 boxes per row and 3 boxes per column. In reality, magic squares are actually matrices. For more information about a matrix, see algebra. They can be odd order, such as a 3 by 3, or 5 by 5 matrix. Or even order, such as a 4 by 4 or 6 by 6 matrix, magic squares. Perhaps the simplest magic square is the 1 by 1 square, whose only entry is the number 1. Such magic squares have been known for centuries. For example, the Chinese knew about the 3 unique normal squares of order 3. In Chinese literature dating from as early as 2800 BCE, a magic square known as the Lo Shu, or scroll of the river Lo, was invented by Fa Hai, who is thought of as the mythical founder of the Chinese civilization.
What are astronomical units in light years?
An astronomical unit is one of the more common measurements used in astronomy. It is a distance equal to the average distance from the Earth to the Sun, or 92,960,116 Halley's Comet, named after Edmund Halley. Last appeared near Earth in 1986 and will be seen again in the night sky in 2062. Stone/Getty Images. Miles, 149,597,870 kilometers, it is often seen rounded off to 93 million miles. 149,598,770 kilometers, and used in reference to great astronomical distances. For example, the Earth is 10 from the Sun, the planet Venus is 0.70. Mars 1.50, Saturn 9.50, and the farthest planet, Pluto, is 39.50 from the Sun. A light year is an even larger unit. As the name implies, it is the distance light travels in 1 year, or about 5.88 trillion miles, 9.46 trillion kilometers. In most cases, light year measurement is reserved for deep space objects. For more about measurement, see Mathematics Throughout History.
What are some special properties of zero?
There are many special properties of zero. For instance, you cannot divide by 0, or have 0 as the denominator bottom number of a fraction. This is because, simply put, something cannot be divided by nothing. Thus, if some equation has a unit, usually a number, divided by 0, the answer is considered to be undefined. But it is possible to have 0 in the numerator, top number, of a fraction. As long as it does not have 0 in the denominator, called a legal fraction, it will always be equal to 0. Other special properties of 0 include, 0 is considered an even number. Any number ending in 0 is considered an even number. When 0 is added to a number, the sum is the original number. And when 0 is subtracted from a number, the difference is the original number. Square of the length of the radius, or as it is often phrased, pi r squared.
What was the main problem with the invention of zero by the Mayans?
Unlike more mobile cultures, they were not able to spread the word around the world. Thus, their claim as the first people to use the symbol for zero took centuries to uncover. For more information about zero, see Mathematics Throughout History.
What is arithmetic?
Arithmetic is a branch of mathematics that deals with numerical computation, specifically. It includes computation using integers, rational numbers, real numbers, or complex numbers. The word arithmetic has its roots in the Greek word for to count. Arithmean, also arithmos, or number. Arithmetic contains all the rules for combining two or more numbers. In most cases, when mathematicians talk about elementary arithmetic, they are speaking of those subjects most of us learned in grade school: addition, subtraction, multiplication, and division being the most common, and fractions, geometry, and measurements. Ratios and proportion, simple probabilities, and algebra examined in more advanced levels. For even more advanced students, such arithmetic lessons as congruence calculation, root extraction, power computations, and advanced factorizations are often presented.
What is a matrix?
A matrix is a concise way of representing and working with linear transformations. Also, it is a rectangular array or grid of numbers or variables that allows the user to perform certain mathematical operations. They are usually symbolized as large parentheses or two large pair of parallel double lines surrounding the array of numbers or variables. These numbers can be manipulated to solve systems of equations or problems with many different variables or numbers by addition, subtraction, multiplication, or other methods. Each row and column of a given matrix must have the same number of elements. Anytime one has a list of numbers, or a table of numbers in a specific order, concerning anything at all: prices, grades, populations, coordinates of points, production tables, it can be considered to be a matrix. When the idea of the matrix was first conceived, its development dealt with transformation of geometric objects and solution of systems of linear equations. Historically, the early emphasis was on the determinant, see below, not the matrix. Today, especially in linear algebra, matrices are considered first.
What are some paradoxes that deal with space and time?
There are numerous paradoxes that deal with the counterintuitive aspects of continuous space and time. One of the most well-known is the dichotomy, or racetrack, paradox. Before an object can travel a distance d, it must keep traveling in halves. In terms of the racetrack, in order to reach the end of the course, a person would have to first reach the halfway mark, then the halfway mark of the remaining half, then the halfway mark of the final fourth, then of the final eighth, and so on ad infinitum, to infinity. Therefore, the distance can never truly be traveled to reach the end of the racetrack. The Achilles and the tortoise paradox is a version of the tortoise and the hare, but with a very different resolution than the well-known fable. In this paradox, Achilles gives the slower tortoise a head start. Achilles starts when the tortoise reaches point A. But by the time Achilles reaches A, the tortoise has already moved beyond that point to point B. When Achilles reaches B, the tortoise is at point C, and so on ad infinitum. Since this process goes on forever, Achilles can never catch up with the tortoise. Another paradox is the arrow paradox. In this case, an arrow in flight has a certain position at a given instant in time. But that is indistinguishable from a motionless arrow in the same position.